Hi, my name is Mary Chris Arcuri. Thank you for joining me today to learn about Sydor's diamond-based X-ray beam monitors. The intensity and position monitors that you'll be learning about today were initially developed at Brookhaven National Laboratory and commercialized by Sydor. Our diamond-based monitors were initially developed to overcome the limitations of alternative monitoring options. The alternative solutions have issues with saturation, linearity, or don't offer the position resolution required for today's light sources. We overcome these limitations by using very high quality diamonds. We offer intensity and position monitors. Our intensity monitors are a single channel device which provides information about your flux and your timing. Our position monitors have a metallized quadrant design on the front of the diamond, and through this, we're able to provide information about the position, the flux, and the timing of your beam. We offer both stage-mounted and flange-mounted designs and offer packages for in-air use, in-vacuum use, and UHV use. Ultimately, we're able to provide our customers with a very low-maintenance solution in a very thin profile. So our packages are very small and able to be located close to your sample. Due to the quality of diamonds that we're using within our monitors, we're able to provide a solution that can span a wide spectral range. So you can have one solution across many energies and get your position and your flux information all in one. Through our extensive quality assurance process, we're also able to omit dislocations and hotspots. By doing this, we're able to enhance the uniformity of the response across the surface of that diamond. We are also able to guarantee a very low dark current, less than 1 picoamp, and also able to ensure flux linearity, which you'll see is over 11 orders of magnitude. Because of the transmission properties of the diamond, you won't see that there's a great impact on the amount of energy that's reaching your sample. You can leave the monitor in situ, and since the diamond is radiation hardened, you're able to leave it in the beam's path permanently. So really great, easy, low maintenance solution. The diamonds that we are using are very thin, and we optimize the thickness of the diamond based on your application to ensure that both transmission and charge collection are being optimized. Here you can see the transmission across various energy ranges for diamonds. For the single crystal electronics grade diamonds that we're using, we can offer various thicknesses based on your energy ranges, and that will be one of the steps through the design process. Here you can also see that we have a very linear response for flux for these single crystal diamonds. As I mentioned, we do have a standard set of packages available. These are stage-mounted and flange-mounted designs. However, we are very happy to customize to any unique requirements. So if you don't see something here that suits your needs, feel free to reach out. We're happy to customize as however you need. So the standard energy ranges that we can supply a product for include monochromatic pink and white beams. The diameter aperture that you typically see is around 3 millimeters, but that can also be modified to meet your needs. And we do offer packages for in-air use, vacuum, and UHV use. Please note that for the in-air solution, the diamond is housed within a chamber with an inert gas. Typically, this is helium. And so let's go on to some examples. So here you can see a few of the different packages that we've supplied in the past. These are just a few of them. Please take a look. Let us know if anything is speaking to you. When you contact Sydor, one of our experts will assist with the entire design process. We'll go through various housing options, determine the optimum diamond thickness, identify the metallization that should be used for your position monitor. If you need a custom metallization pattern outside of that quadrant design, we can go ahead and evaluate that. Also, if there's any translation requirements, our mechanical engineers can help you design your motorized stage. For the stage translation, our monitors are compact. Again, like I said, due to the properties of the diamond, you can leave it in place, operate in situ. That's totally fine. You can leave it in place permanently, but if you opt for a stage mounted design and do want to remove it from the path of the beam, just a few millimeters and you're able to get the monitor out of the beam's path very easily. Also, based on the amount of heat that's being generated within the diamond, we may have to go ahead and suggest cooling. So we do have a few different cooling options for you as well. Our standard designs are not cooled. However, we do also offer passive and active cooling. So one of our engineers will walk through a simulation and will be able to identify whether or not you'll need cooling for your solution. On the right side of your screen there, you can see this is a design that we went ahead and made that required a lot of cooling. It was very high heat loads. They also required XY translation, and this was for use in vacuum. So we do offer solutions that can be used for the beam lines that are already built today and ones that are being designed in the future. So we have a very broad portfolio, and again, are happy to customize to your unique needs. Now that we have all that data collected, we need to read out that information. So we offer two different types of readout electronics. The first is the Sydor Advanced Electrometer, and the other one is the Sydor Basic Electrometer. Both of these provide the bias to the monitor and also can read out those 4 channels, and they detect current down to the picoamp level. Both have Ethernet communication, so easily integratable with your control systems. What's unique about our advanced electrometer is that it has an embedded PID loop, so that can be paired with peripheral equipment, such as your mirrors, your various optical components, to be pre-programmed to allow for only a certain amount of drift. So if you're very susceptible to things like thermal drift or vibrations and whatnot, and stability is really important, we can make sure that that is all automated. And the user can specify an allowable amount of drift or offset. As you can see here, there's a lot of beam stability when the feedback is turned on. However, once that feedback loop is turned off, you can see that there's drift in the Y position. Here you can see an example of what the software interface looks like. You can see your XY position in real time. You can see the various amounts of current coming out of each of your 4 channels. You can control your bias, and you can pre-program your feedback for the advanced electrometer. As I mentioned earlier, the beam monitors were initially developed at Brookhaven National Laboratory and commercialized through the SBIR program. We have another project that is currently in the works. This is the transparent X-ray camera. This is essentially a pixelated beam monitor, which provides information about your position, your flux, and your beam profile. So in real time, you're able to get that information about your beam profile, so you don't have to use things like burn paper anymore. Ultimately, this will be a time-saving technology, and here you can see some of our target specifications. If you'd like some additional information about this product as it becomes developed, please reach out to us, let us know, and we'll put you into contact with one of our team members. Thank you so much for your time today. We really appreciate it. We are happy to discuss any customizations that we can provide for you, and we really want to be here to help you achieve your research objectives. So there's some of our contact information. Visit our website, and we hope to talk to you soon. Thank you.